Hello everyone, welcome back to my channel Gemsofknowledge. So today we are going to deal with the chapter circles of class 9th. So till exercise 12.3 we have completed. So in the today's video we are going to deal with the exercise 12.4. Okay, so you know the drill. Before starting the video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new videos. So here the first question is given: two circles of radii 5 cm and 3 cm intersect at 2 points and the distance between their center is 4 cm. So here you can see two circles. One, the bigger circle is of 5 cm radii and the smaller one is of 3 cm radius. Okay, and the distance between these two is nothing but 4 centimeter. So what we need to find, we need to find the length of this chord. Okay, this is the common chord for both the circles, the bigger one and for the smaller one. So we need to find out the length of this. Okay, so let us write what is given here. So this figure is not present into the textbook. We need to draw this figure as the answer. Okay, so the just a sample figure I have drawn. So let us see what is there with us. Given okay, the bigger circle we are having as 5 centimeter. Okay, so just you can see what is given. So I will mention this r. Okay, this bigger circle of radius 5 centimeter as r. So it is having the radius 5 centimeter and the smaller one is having the 3 centimeter radius. Okay, next, what is the length of the common chord? We need to find out the length of the common chord to prove length of CD. Okay, we need to show what is the length of CD. Okay, next we know that one more thing, we can write this AC as 5 centimeter as this is the radius. So proof we will write. We know that AC is equals to 5 centimeter. Okay, this is the radius of the greater circle. This is 5 centimeter. Okay, and we also know that this is the center point of this circle. Okay, so this BC is equals to 3 centimeter. Okay, we know all these conditions. Then we can directly write chord CD is equals to 2 into BC. You can see BC and here it is BD. Okay, BD in the sense this is also the radius of the smaller circle. So we can write 2 times BC. So which is equals to 2 into 3 equals to 6 centimeter. So the chord we get is of 6 centimeter. Next you can see the question: if two equal chords of a circle intersect within the circle. You can see two chords inside the circle, that is AB and CD. These are the two chords inside the circle and they intersect at a point E. Now what we need to prove is prove that the segment of one chord are equal to the corresponding segment of other chord. Okay, so segment in the sense this AE, what we need to prove is, you can see this AE is equals to this CD we have to prove, and this ED is equals to this EB we have to prove. Okay, so let us write what is given. This is also inside the solution, the figure is not present here. Okay, let us write what is given. They have already given us that two equal chords, so we can write AB is equals to CD. Okay, and they intersect within the circle. This is what they have given, AB is equals to CD. What we need to prove, we need to prove that AE is equals to this CE and ED is equals to EB. Okay, ED is equals to EB we have to prove. Okay, so one construction we will make here, that is we will draw a perpendicular to this line and we will write this as M, and similarly we will draw one more perpendicular over here and we will write this as N, and let us also join this OE. So we can write OM perpendicular to AB. Okay, this is the line AB. OM is perpendicular to this line AB, and ON is perpendicular to CD and join OE. Okay, this is the construction. Now after construction, let us consider the proof for this. That is, we will consider these two triangles. Consider triangle OME and triangle ONE. Okay, OME this triangle and ONE this triangle. Okay, so after considering both the triangles, what we can say is OM is perpendicular to AB and ON is perpendicular to CD. So we can write OM is equals to ON since perpendicular bisectors. Okay, since those both are perpendicular bisector, then we can write for both the triangles this OE is common side. OE is equals to OE, we can write it as common side. Okay, then one more thing we can write, this angle if it is perpendicular it will be at 90 degree. So we can write OME is equals to ONE, which is equals to 90 degree right angle. Okay, perpendicular angle. So if this is 90 degree, we can write triangle OME is congruent to triangle ONE since RHS rule. Okay, since RHS rule, we can say that both the triangles are congruent. If both the triangles are congruent, we can say that ME is equals to NE since CPCT, corresponding parts of congruent triangle. We can say that this line ME is equals to this line NE since it is corresponding parts of this congruent triangle. Okay, next, in this ME is equals to NE only, if we add AM and this side if we add NE plus CN. Okay, if we add AM here and if we add CN here, we get AE is equals to CE. This is what we need to prove in the first. AE is equals to CE. As you can see, if we add CN part, we get this part, and here if we add AM part, we will get this part. Okay, so we got the first thing what we needed, that is AE is equals to CE we got. Okay, in the second case we needed this part. So what we will do is AB, okay, we know that AB is equals to CD, correct? We know that AB is equals to CD, but in the AB if we remove AE and here if we remove CE, okay, this one only, equation 1, if we subtract equation 1 in this, what we are going to get is in AB if we remove AE, what we are going to get is EB. And here in case of CD, if we are removing CE, we are getting ED. Okay, so we are getting ED. So this is what we need to prove, that is ED is equals to EB and here AE is equals to CE. Hence you can write hence the proof. Okay. Okay, you can see the next question, third question. If two equal chords of the circle, the same question they have given, same figure it follows. Okay, so this is the solution. If two equal chords of the circle, these are the two equal chords of the circle intersecting within the circle, what we need to prove that the line joining the point of intersection, this is the point of intersection. Okay, so the point joining this point of so the line joining the point of intersection to the center, okay, this is the line which is joining to the center, it makes equal angles with the chords. It means we need to show that this angle is equal to this angle, we need to show it. Okay, how is this possible? The same thing you have to write. What is given? Given is nothing but AB is equals to CD is given. Okay, what we need to prove is, to prove this OEM, angle OEM is equals to OEN, we have to prove. This side we have to prove. Okay, so construction, you know what you have to do, same construction, that is OM is perpendicular to AB and ON is perpendicular to CD, then we need to join OE. Okay, this is the so this is the construction. Okay, next proof, same thing, consider two triangles, consider triangle OME and ONE, triangle ONE. Okay, so in that what we will get is OM is equals to ON since perpendicular bisectors. Okay, then we can write OE is equals to OE, common side. Okay, again we can write OME, angle OME is equals to ONE, which is equals to 90 degree. Since we can write both the triangles, that is OME is congruent to triangle ONE, since RHS rule. Okay, since if this is congruent, then we can say that this angle is equal to this angle. Since in the second problem we wrote that this is equal to this, that is ME is equals to NE we wrote. Similarly we can write this angle is also equal, because CPCT, that is OEM is equals to OEN, since CPCT. That's what we need to prove. Okay, so we'll move on to the next question. Okay, moving to the fourth question, as you can see, if a line intersect two concentric circles, so these are nothing but two concentric circles. Concentric circles means circle, both the circles will have only one center and they will be having the different radius. So if this is 2 centimeter circle, this might be 4 centimeter circle. So with the same center, they are having 2 to 3 different radius. That type of circle is known as concentric circle with the same center. With center O they have given, and at A, B, C and D. Okay, so this line is intersecting these two circles at A, B, C and D. Prove that AB is equals to CD. We have to prove that this part of AB is equals to this part of CD. We need to prove. Okay, so what we will write is, given, they have given two circles are concentric. Okay, they have given us that two circles are concentric. Okay, what we need to prove is, to prove AB is equals to CD. Okay, then one construction we need to do here, that is we need to join this OP. Join OP. This is the construction we need to do. Okay, and we also know that join this OP. Then we will consider this proof. In the proof we know that if we consider AD as the chord of the bigger circle, so if we will write AD is the chord of bigger circle, okay, then we can say that AP is equals to PD. As you can see, this AP is equals to PD, we can say. Okay, we will consider this as equation 1. Okay, then if BC is the chord of smaller circle, then we can say that BP is equals to PC. This is equation 2. This BP is equals to PC we can write. Okay, then from equation 1 and 2, we can say that in AP, if we cancel BP, that is AP minus BP. See, AP minus BP is equals to PD minus PC. Okay, just see, in AP, in this AP, if we cancel this BP, we are getting AB. That is, here we will get AB, which is equals to, in this PD, if we cancel this PC, okay, we are getting CD. That is what we needed. AB is equals to CD. Okay. Okay, the next question, fifth one. Three girls, Reshma, Salma and Mandeep, are playing a game by standing on a circle of radius 5 centimeters. So you can see this is just an example of the radius, which is of 5 centimeter, drawn in a park. Okay, so you can see three girls named, this is Reshma, Salma and this is Mandeep. They are standing on a circle of radius 5 centimeter in a park. Okay, Reshma throws a ball to Salma. So Reshma is throwing a ball to Salma, and Salma to Mandeep, and Mandeep to Reshma. Now Mandeep to Reshma. If the distance between Reshma and Salma and to Mandeep is 6 meters. So RS is 6 meter and SM is 6 meter. Okay. What is the distance between RM, Reshma and Mandeep? What is the distance between RM we need to show? So what we will write given? First, radius R is equals to 5 meter they have given. Okay. Radius of the circle is 5 meter and the distance between RS and SM both is equals to 6 meter they have given. Okay. What we need to prove? We need to prove that distance between Reshma and Mandeep. Distance between Reshma and Mandeep RM is equals to how much we need to show. Okay. A small construction we will do here. We will join this, draw a perpendicular bisector over here and we will name this as X, and one more perpendicular bisector to this SM and we will name this as Y. Okay. So OX perpendicular to RS and OY perpendicular to SM. We will do this construction. Okay. Okay. Then let us start with the proof. What proof we are having? Okay. So we know that OR, OM and OS, both all the three are the radius of this circle. So we can write OR is equals to OM is equals to OS, which is equals to 5 meters since radius of circle. Okay, since these are the radius of the circle. Now if OX is perpendicular bisector of RS, then RX will be, see, Rx is equals to XS is equals to, this is 6 centimeter. If this is exactly the perpendicular bisector, then Rx will be equal to 3 meter. Since what we will write is OX is perpendicular to RS. Since OX is perpendicular to RS means it is equally dividing. This OX is dividing this line into equally two parts. So we will get exactly half of the distance. If this is 6 centimeter, this part will be half, means this is 3 centimeter, this is 3 centimeter. Okay. Next we will move on. So in triangle ORX, now consider the triangle in triangle ORX. Okay. ORX. See, we know that OR value we know, RX value we know, we have to find the value for OX. So this is according to Pythagoras theorem. OR square is equals to, see, OR square, this is the hypotenuse side, is equal to this side plus this side. Okay. So OR square is equals to OX square plus RX square. Since Pythagoras theorem, this is Pythagoras theorem. Okay. So OR square we know that is 5 meter. OR is 5 meter. So 5 square. OX is, we don't know. We'll keep it as OX square as it is. Plus RX we came to know that is 3 square. Okay. 5 square is 25. 3 square is 9. If you bring this to this side, it will become minus, which is equals to OX square. So 25 minus 9 is 16, which is equals to OX square. So OX is equals to, if you remove this square to this side, so if you remove this square to this side, it will become root of 16, which is equals to 4 meter. Okay. So we got OX is equals to 4 meter we got. OX is equals to 4 meter. Okay. We got. Okay. We will keep this as it is. Now we will consider this figure as a quadrilateral, as this is having 4 sides. OR, OS, SM and OM. 4 sides. Okay. Consider the quadrilateral. Consider the quadrilateral, that is ORSM. Okay. So ORSM, in that we can write OR is equals to OM, already given. OR is equals to OM since radius. Okay. Then again we can write RS is equals to SM. So RS is equals to SM, which is already given because data, from the data. Now you can see this sides both are equal and this sides both are equal. So adjacent sides are equal, means this quadrilateral is, therefore quadrilateral is a kite. Quadrilateral is a kite since all the adjacent sides are equal. Okay. Now if it is a kite, therefore we can say that this angle, we will name this point as A. Okay. Now we can say that RAO is equals to 90 degree. If it is called a kite, then this angle will be of 90 degree. Okay. Then we can say if it is 90 degree, then we can say that RA is equals to AM. This is equal since kite. Okay. This side RA is equals to AM. Now we will consider the triangle OR and A. Okay. Now we will consider the triangle OR and S. Okay. So consider triangle ORS. In that we will consider that RS is the base. In the first case, if RS is base, then we can write area will be equals to, okay, area is equals to half into base into height. So what is base? We have already taken RS is the base. RS is the base into height. What is the height? OX is the height. So OX is the height. So substitute half into RS value is, okay, we got RS value here only we are having RS is equals to 6 meter. So 6 into OX we got, that is 4. So 2 ones are 2 twos are, we got 6 twos are 12 meter. We got area to be as 12 meter square. Okay, we got one area. Now in the second case, if we consider OS is the base, if OS is base, then area will be equals to, just look here, if this OS is the base, then the height will be RA. This is the base and this will be the triangle. So this will be height. RA will be height. Okay. So you can see area is equals to again half into base is OS. OS we are having as, you can see OS we are having as 5 meter. So half into base, that is 5 into height. Height is RA. We don't know. So height is RA. We don't know the value for RA. So what we will do is, already we got area, no? That is 12 meter square. We will substitute here. 12 meter square is equals to half into 5 into RA. Okay. So this is, if you multiply here, 12 into 2, if you cross multiply this, it will become 12 to the 24. Okay. 24 meter square divided by, if this 5 comes here, it will become divided by, which is equals to RA. So we got the value of RA will be equals to 5 ones are 5, 5 fours are 20, 4 is remaining, and point, if you put one more 0, this will become 40. So 5 8s are 40. So RA is equals to 4.8 meter. Okay. So just see, we got the value for RA. Now this RA is equal to AM. We have written somewhere, as you can see, RA is equals to AM. So totally RM is equals to, so totally you can write RM is equals to RA into 2 times. Okay. Since RA is equals to AM, so you can write both as 2 times. So 4.8 into 2 is equals to, if you multiply, 2 8s are 16, 6 and 1 carry. So 2 4s are 8 plus 1 is 9. 9.6 meter you are getting. Okay. Okay. So the last question of this exercise, you can see, sixth one, a circular park of radius 20 meter is situated in a colony. So this is the circular path which is having the radius 20 meter. Okay, so radius means OA will be equals to 20 meter. So let us write the data which is given R is equals to 20 meter. Okay, then the 3 boys, Ankur, Syed and David, are sitting at equal distance on its boundary. So Ankur, Syed and David, they are sitting at equal distances. Means we can write equal distances in the sense, we can write AS is equals to ST is equals to AD. We can write all are equal, since they have given us in the question. Okay, having a toy telephone in their hands to talk to each other. Okay, they are having a toy telephone in their hands to talk to each other. Find the length of the string of each phone. Since all the three are equal, so what we will do is we will find the length of AS. Okay, so this is given. What we need to prove? To prove length of AS. Okay, if we find out one, we will get the length of all the two. Length of AS is equals to question mark. Now let us start with the proof. Okay, they have already told us that AS is equals to SD is equals to AD. Therefore, ASD, we can say that is an equilateral triangle. Okay, since all the three sides are equal, we can say that it is equilateral triangle. Okay, then one more thing we are having, that radius OA we are having as 20 meter. You can see OA is 20 meter since it is radius. They have already mentioned since radius. Okay, then what we will do is, if this is the radius, we can say that AB is median of the triangle. Okay, this AB is median and it is dividing into 2:1 ratio. Just you can see this length OM is the length smaller than OA, because you can see OB, this is since the half, but this OA is touching to the circle. This is not touching to the circle. So we can say that it is the median and dividing the circle and divides into 2:1 ratio. So it is dividing into 2:1 ratio. So we can write OA is to OB. This OA is to this OB is equals to 2:1. This OA is 2 times, whereas this OB is only 1 time. Okay. So now this means we can write OA divided by OB is equals to 2/1. So if we cross multiply over here, what we will get is 2OB is equals to OA we are getting. Okay, 2OB is equals to OA. OB is equals to OA. If you bring this 2 to this side, it will become divided by 2. Okay, this is nothing but divided by 2. So OB is equals to OA value we know, that is 20 meter already given, divided by 2. 2 ones are 2 tens are. So OB we got value as 10 meter. Okay, already we got OB is equals to 10 meter we got. Now AB is equals to OA plus AB. Now our AB, totally AB, you can see totally AB if we want to find, we have to write OA plus OB. Correct. So which is equals to OA plus OB, that is OA we are having 20 plus 10, which is equals to 30 meter we are having. Now we will consider this triangle ASB. Okay. In triangle ASB, we can write this AS square, the Pythagoras theorem if we take, we can write AS square is equals to AB square plus SB square. So what we will get is, see, as you can see, this is AS hypotenuse, this is equals to SB square plus AB square. Okay, so we know the values. AB we got it as 30 square plus SB so we don't know the value of SB here. So what we will do is, SB is equals to half of this SD. So SB is half of this SD. So we will write half of SD. This is square will be as it is. Okay. Now we will keep this AS square as it is here. We don't know the value of AS also and we don't know the value of SB also. Okay. So AS square is equals to, this is 930 square means this is 900 plus, okay, 1 by 2 square means it will become 1 by 4. Okay, and SD square means instead of SD here, can we write it as AS because both are equal? So we will write here AS square. See, separately I have squared here, half square into SD square. Half is 1 by 4 2 times, okay, square, and AS S in place of SD square, I have written AS square since both are equal. Now we will bring this 1 by 4 of AS to this side. So it will become AS square minus 1 by 4 AS square is equal to 900. Okay, so if we take common AS square as common, we are left with 1 minus 1 by 4, which is equals to 900. Okay, so now we will get, for you can see here, AS square, 4 ones are 4, 4 minus 1 is 3, 3 by 4, which is equals to 900. So let's move this to this side. So we are getting AS square is equals to 900 into 4, okay, divided by 3. So 3 ones are 3 threes are 9, 300 into 4 we are getting. Okay, so let me continue from here. So AS square, okay, AS square is equals to 3 fours are 12 and 2 zeros. This much we are getting. So AS is equals to root of 1200. So this can be written as 400 into 3. 4 threes are 12. Okay. So 400 means we are getting 20. 400, square root of 400 is 20 and into root 3. So AS value is 20 root 3 meter. Okay, so we can keep this AS value, we got 20 root 3 meter, and same thing this will be, that is SD is also 20 root 3 meter and AD is also 20 root 3 meter. So I hope you have understood with this exercise. If you are having any doubts regarding this, you can comment me down below, and don't forget to like, share and subscribe to my channel. I'll be back soon with the next video, that is exercise 12.5. So till then, stay tuned and stay connected. Thank you.